Have you ever wondered what happens to a star when it dies? Well, there are actually three possibilities. Small stars slowly shed their layers and turn into white dwarfs, whilst larger stars go supernova and leave a neutron star and matter behind. But what is really interesting is when massive stars die. The star's core suddenly collapses upon itself, and that force is so strong that nothing can prevent it. It'll just keep on collapsing into an infinitely small point known as the singularity. That point contains the entire mass of that star. These types of black holes are called stellar mass black holes. A second type of black holes are supermassive black holes, which we believe to be in the center of every large galaxy and live on for up to 10 to the power of 100 years. That's 1 with 100 zeros. Now I want you to keep in mind that black holes don't live forever, because I'm going to get to that in just a sec, right after we look at the anatomy of black holes, so that you'll understand what I'm talking about later. So let's start off with a black circle representing the black hole. But because a black hole absorbs all the light that passes the event horizon, we can only see its sort of shadow. Further out, we got the photon sphere, where light can orbit in a circular motion around the black hole before it falls in. If you were to stand here looking straight, you'd be able to see the back of your head because the light that you see actually traveled around the black hole. Even further out, we got the accretion disk. This is a spinning disk that consists of extremely hot matter, which orbits the black hole at roughly half the speed of light. But not all black holes have accretion disks. So now that you know a little more about the anatomy of black holes, we can get back to what I was talking about, how black holes don't live forever. Now this is going to get a little more complicated, but bear with me, I'm going to try to explain it as best that I can. So due to quantum fluctuations, which essentially says that matter and antimatter pairs are randomly created at the same time, but only for a very short time before they merge and eliminate themselves. But if this happens on the event horizon of a black hole, then there's a possibility that one of these particles would fall into the black hole, leaving its partner particle being able to escape. This escaped particle is what is known as Hawking radiation. These escaping particles are also the reason that black holes slowly shrink and lose mass over time. But also they will die someday, and after all that, there will be nothing left. But that's not going to happen for another long time.